Hello everyone, welcome back. My name is Akal, instructor at Akalcom Network. I'm so excited to be teaching you networking configurations. So what you see in our screen here is a very complex network that we're going to configure. And in the end of this session, you'll be able to understand a lot of concepts. So this lab requirement require you to have a very powerful PC. So we have got three firewalls, so meaning that when we run all the three firewalls, somehow uh, the devices will lag your PC. So it needs a very powerful PC. Maybe if you have a RAM of 16, it will be very good for you. Mine is a RAM of 8. At some point, I will only have to start only a few devices and leave others, because when I start all the devices, all everything will hang and I won't be able to show you how you can do this beautiful configuration. So we're going to see our task, what is required. So one of the students who normally follow my videos inboxed me and told me they needed assistance on how they can configure this Huawei ICT competition 2022-2023 regional lab, and I have taken my time to go through the lab. So I have prepared a configuration tutorial, and in this tutorial we are going to encounter VLAN configuration. We're going to see how we can do our IP planning. Also, we're going to do MSTP configuration, security on firewalls, VRRP or standby and security configuration on firewalls, configuration of static public network routes. We're going to also see dynamic routing configuration for the public network. We're also going to implement MPLS to enable label switching in our MAN network. So this one is where we are going to apply the carrier and the lease network. So at the end of it also, we will need to configure the WLAN configuration for our wireless access. So in the background, it says the competition simulates the scenario where a large enterprise network connects to a data center through the WAN. To meet the network redundancy and load balancing requirements, MSTP is deployed on the enterprise network, and firewalls are deployed in host standby mode to transmit our web services and internet access services. In addition, the WLAN services need to be deployed on the enterprise network to provide internet access for employees using wireless terminals. When enterprise networks and data center networks are being built with the abundant network resources, they are also facing severe security problems. To ensure security risk, next generation firewalls can be deployed at the egress of enterprise networks and data center networks to implement secure and efficient network management. The private cloud on the enterprise is deployed in the equipment room on the HQ data center. Various services system of the enterprise are deployed on its private cloud, and the web server on which the enterprise ORA system resides is deployed in the HQ data center. Branches of the enterprise need to access the web server in HQ data center through MPLS VPN. For security purposes, the private IP network address of web server is not advertised to the WAN. Instead, public IP addresses 100.1.1 is used for access to web server. A web client can access the web server only when the destination address of the traffic from web client to web server is translated into the private IP address of web server on firewall 3 in the data center. To implement mutual access between the service VM1 and 2 in different subnets in the HQ data center, GRE tunneling must be deployed in the data center to establish a layer 3 channel between VM1 and VM2. One connects the enterprise internet to the HQ data center. MPLS VPN is deployed on the one to deliver the internet leased line function, thereby isolating service of the one. So that is the background. That is what we are going to configure in this entire lab. When you look at the picture here, you can see the topology. These are the topology that we've implemented on our ENSP. So the following are the devices that you are required. When you check in the description, you will see where you can find out find this lab. Now, these one are just showing you, demonstrating to you how you can configure those routes, or you can make sure the routes are reachable. So this part, we are going to see them as we proceed. But we have to begin with just step one, that is VLAN configuration. I presume you have watched several videos in my channel, so you know how to configure VLANs on interfaces and allow the respective VLANs to pass. So because this lab is very huge, I'm not going to configure every interface on this lab. So some interfaces I've pre-configured so that we make sure the video is very short so that you don't get bored with a lot of information. But here, I'm going to show you where you might find very difficulty in configuring the .1 queue termination on the firewall interface and also on the router interface. When you look here, you see that firewall 1, the link type here is .1 queue, but on these other devices, the link type will access or other trunk. Now, in a situation where you are given a link type to be .1 queue, how do you go about it? Maybe you've never met such kind of thing. You are meeting with this for the first time. So that is what I'm going to show you, not those other interface configuration that we have seen on different labs. Those one I believe you can do. So you're going to start with a firewall 1 and configure the .1 queue termination link type. So enter your firewall 1. Username was admin, and I gave it a password of Huawei at 123 as suggested by the lab. We are going to undo terminal to prevent the pop-ups. So then enter the system view. So sometimes you find that when you start your USG firewall, because this lab requires us to use a USG firewall, it may refuse to start. But make sure always when you start your USG firewall, you start it when you are connected on an internet access. Or make sure also your firewall on your PC is turned off. So the first step here, I see my screen is very transparent. I want you to see through the lab. So on firewall 1, we have got interface. We have got two interfaces that implement .1 queue termination. That is one of 105.1. So we're going to enter that interface. Interface gig1/0/5.1. Then we are going to implement a .1 queue termination. To implement .1 queue termination, we just give it VLAN type. VLAN type here, then we give it .1 queue termination. Now, because we were told that the VLAN settings here, we are on VLAN 10. So gig 1, we have to give it VLAN 10. So VLAN, when you question, you can see that it is required you to enter the integer, that is 10. After that, we are going to configure for the next interface, that is 102. 102, also give it a VLAN type here. Its VLAN ID will be now 20. Then we proceed. So we are done with the interfaces for the .1 queue termination. There's also interface gig 103.1. 103.1. 103.1 has a VLAN ID of 1. So VLAN type .1 queue VLAN ID here is 1. You enter. So I think we are done. We are done with that firewall 1. So you control and save your configurations. Say yes. So after we are done with this firewall one, I hope you've seen how you can configure the .1 queue termination link type on your firewall. For firewall 2, I have done it initially, so to simplify the work. So this one was just assisting you to see how you can do that. Now, we are also required to configure that VLAN .1 queue termination on the router. So the one I just showed you was just on how to configure it on a firewall. Now here we have got PE1. PE1 is a router. We are required to configure a .1 queue termination link type, and the VLAN ID is 1. So under those circumstances, you also need to know how you can configure for the router. So we're going to enter the interface of the router and see how you can do that. Like I said, sometimes we will encounter the system hanging because the devices are so heavy, but you'll just be patient. So after that, we are going to enter the interface to which we are going to configure the VLAN type. So on that router, so we are going to enter interface gig 0/0/1.1. After that, to configure the link type as the VID, we are going to use the command control VID. Here we said we are going to use VID of 1, so 1, and we are going to tell it .1 queue termination. So that is the command that you use when you are going to configure the link type on a sub interface of a router. So when that is done, we are going to enter interface for VLAN 103.1. Enter for VLAN 103.1. On VLAN 103.1, we are going to also give it the same command because it also required to have a VLAN ID of 1. After that, Control Z and save your configuration. When done, we are going to move to the next step. So we are done with the link type of .1 queue termination that you might have found very new to yourself. You've never met it. After the VLAN configuration, we are just going next. We are going to do what is called IP configurations. Again, for other devices have done the configurations, and the configuration that for the IP that I'm going to show here is just for the VLAN for the sub VLANs. So like on firewall 1, we are going to configure IP address on gig 103.1 up to 103.5. So I'm going to enter firewall 1's interface. Let me move it sideways so that you can see it. Okay, so enter to the system view, enter the interface for interface gig 1/0/3.1. That is the sub interface. We're going to display this and see what is on that interface. Display this. It just only have a .1 queue termination link type on its interface. So we're going to give it IP address of its IP address is 10.2.2.1. 10.2.2.1 with a mask of 24. Then we enter interface for gig 105.1. Then IP address will be 192.168.1.2, 192.168.1.2 with a mask of 24. Then lastly, we enter for interface sub-interface for .2. So IP address here will be 192.168.2.2 in the mask of 24. After that, we are done with that configuration. Firewall 2, the configuration steps are similar, so I have done it on the other firewall. So that one is demonstrated how to configure IP on that interface. After that, make sure you save your work. So save your work. When that is done, IP configurations, all these ones are just similar to what I have done. I believe you know how you can configure IP on an interface. You just give interface, then give it the IP address. The ones that you could have found a problem was for the IP address for the sub interfaces. So we're going to configure the IP address for sub interface on router number 1. So let's give it IP address system. So you're going to enter interface gig 0/0/1.1. Display this and to see what's on that interface. It just has .1 queue termination. Now we are going to give it IP address of 10.2.2.2, the mask of 30. Enter. Then enter for gig 103.1. IP address will be let's see the IP address 103. IP address will be 10.3.2.2, the mask of 30. So after that configuration is done, we are through with the IP address configuration. Now we are going to move to our next step. So in the demonstration, I have showed how you can configure VLAN and VLAN types. The next, I showed how you can configure IP on a sub interface. Now we proceed with our next lab. Now we are now going to base our thorough configuration on, that is multiple spanning tree protocol, MSTP. So MSTP helps curb loops in our network. So like in the case where you see here, we have got 3-layer 2 switches, which will now help to implement redundancy. So in case one of the switch fails, the other will be able to take over to ensure flexibility in our network. But now the problem that it is brought by redundancy is that it causes loops in our network. To curb that loop, you use what is called spanning tree protocol. Now you are told that you're going to configure a spanning tree protocol between the two switches. So let's see what the lab requires to do. To implement loop prevention and load balancing on the layer 2 network, configure MSTP on switch 1, switch 2, and switch 3. So guys, I'm going to do something because now to prevent us from our system hanging, we're going to stop one of the firewall so that we remain with the other two networks that are stable. You see it's going green and red, meaning that it is not stable. So we want to turn one firewall so that at least it becomes stable. Okay, you can see now it's constant at green. Now we are going to implement that MSTP we were just told. Now step 1, set the region configuration on as to RG. So we are going to start with our first switch, UTM, and do terminal monitor, enter system view. In the system view, first of all, we're going to enable MSTP on global view. So STP mode here we use MSTP. So MSTP is used by default by Huawei switches. So even if you don't configure, it will be picked by default. Now after that, we are told now to configure the region configuration. So meaning that you're going to say STP region configuration, enter. Then the region name here, they told you to use RG1. That is the step number 1. Let's see step number 2. What step number 2 says? Map VLAN 2 through 10 to spanning to instance number 1, and map VLAN 11 to 20 through instance number 2. So we go and implement that. So while you are on from our step number 2, we are told that you are supposed to bind VLAN 2 to 10 on instance 1. So instance 1 VLAN 2 to 10. Then instance 2 VLAN 10, VLAN 11 to 20. So steps 2 is done. Let's go to step 3. Configure switch 2 as the root bridge. So let's finish first of all with our instance configuration. So after that, we are going to make sure the VLANs that we've bound to the interfaces take the effect. So we configure the command active region configuration for the commands to take effect. So meaning that we know that all these series switches must have MSTP configuration. So in also this one, we're just going to do the same. UTM as so after that, now what we do is that we just tell it STP mode here will be MSTP, then STP region configuration. So they said region name here will be RG1. Then on instance 1, we bind VLAN 2 to 10. On instance 2, bind VLAN 11 to 20. Then we are going to configure active region configuration for the command take effect. We come to our last switch 3 and do terminal monitor. TP mode here MSTP. So STP region configuration, region name here will be rg1. So instance 1 VLAN here will be to 10. Instance 2 will have VLAN 11 to 20. So we've configured, and now tell it active region configuration for the MSTP to take effect. So we are done with that. We have configured the MSTP on both the 3 switches. Now we continue with our lab. Configure switch 2 as the root bridge on instance 1 and secondary root bridge on instance 2. Configure switch 3 as the root bridge on instance 2 and secondary root bridge on instance 1. Okay. So they said on instance 1, we are going to exit and configure the root bridge on, quit. I was using the exit command. The exit command we use on Cisco. So here we're supposed to use quit. So what is say STP? We are told to configure root bridge STP instance 1. We are told that instance 1 it will be root primary, then STP instance 2 will be root secondary. That one is on switch 2. Now when you come to switch 3 here, quit. So STP instance 1 root here will be now on instance 1. On switch number 3, instance 1 will be now root secondary. Then STP instance 2 will be root primary. Okay, we are done with that step number. It was step number 3. Now we are going to step number 4. On switch number 2, enable STP root protection on interface gig 1 and disable STP on interface gig 5. So that one is on switch 1. We are going to enable STP protection on gig 1 and disable STP on interface gig 5. So gig 1 is this one. Then gig 5 is the interface that connect to the firewall. It's not supposed to allow STP. So interface gig 0/0/1 STP, let STP enable, then STP root protection. So you tell root protection as the practical just suggested, then you quit. Interface gig 0/0/5. We are told to disable STP on that interface. So undo STP enable, not edge port, undo STP enable. That one will be able to stop BPDU generation on that interface that connects to the firewall. And now we are done on switch 1. As the practical proceed, it tells that on switch number 3, enable STP root protection on gig 2 and configure gig 1 as STP edge port and disable STP on this interface that connect to the firewall. So okay. So This one is switch 3. This interface that connect to AC, it connects the terminal. Now we'll configure it as an edge port, but gig 2 here we're going to enable STP protection. So interface gig, we start gig 0/0/2 STP. I believe STP is enabled by default on interface, but let's just enable it. STP enable. Then STP root protection. Enable STP root protection on that interface. Quit and configure interface gig 0/0/1 that connect to the terminal. So STP edge port enable. You're going to enable edge port. So an edge port is a port that when it's enabled with STP, it will enter the forwarding mode after receiving the BPDU. Now we are on interface gig 5. Now we are going to disable STP on gig 5. So you undo STP enable. STP enable. So then quit. So we are done with that. As the practical proceeds, let's see what's on our last step. On number 5, configure Ethernet 1 and Ethernet 2 of switch port number 1 as edge ports, like the one we just configured that connect to the AC. So on this switch 1, all these two interfaces are configured as edge ports because they connect to the terminal. So quit. Then we are going to say interface Ethernet 0/0/1 display this. So you can see here it has been configured as an access port. An access port is a port that connect to the terminal. Then it has been enabled with a default VLAN of 10. So after that, what we do is now to enable STP. So STP edge port enable for it to enter the forwarding state immediately after it has been enabled with BPDU. The same we go to gig 2 interface first Ethernet 2. We do the same. We enable edge port. So Control Z and save your configurations. So yes. Make sure you save all configuration of all the devices. Control Z, save your configurations. Say yes. Save. Control Z, save your configurations. This one will help you now as you revise later. You have the configurations. So we are done with that. Let's see what we need to display. So we are going to verify our configuration. So to verify the configuration that we have done, we are going to enter and say display STP brief. So when we display STP brief, we are going to see here, this one is instance ID. So instance 1, we have got gig 1 and gig 3. They have been configured as designated port, and they are doing what is called forward. They are in forwarding state. BPDU protection has also been enabled. So this one is the root. So we enable it on gig 1 and also on instance 2. Again, let's display STP interface gig 0/0/3 brief. When you display that, you can see now its role is it's a designated and the state is forwarding, the protection is none. So I think we are done with the MSTP. Now this part is implemented, the multi tree spanning protocol is done. So I think our first lab is the first tutorial. We are going to stop at that point. In our next tutorial, we are going to configure security zone on firewalls and also implement a VRRP or standby and security policy. That's going to be our module 2. Then in our module 3, we are going to ensure a connectivity, going to configure configuration and a dynamic routing protocols like that. Then in our following lab, we'll configure MPLS VPN. So I believe at least you've grasped something. The good thing with this thing is that as you practice, you will get to understand and also be able to be acquainted with what it is being done here. So I normally say pause the video, practice it up, and let's meet in our next lab. So thank you guys. Stay tuned for our new episode. So thank you very much.